Welcome to Math Group. Today we will learn about quadratic formula. Okay, so this formula is being used to solve any quadratic equations, to find the roots, or you can say that zeros of the quadratic equation, right? So let's begin. So first, see what is the quadratic equation, right? So quadratic equation is a polynomial of degree 2, right? You can see degree 2 in the form of x square plus bx plus c, where a, b, c are the constant, x is of course the variable, and a should not be 0. Why a should not be 0? If a is 0, in that case it would be like 0 into x square plus bx plus c. So this would become 0, and then it would become bx plus c, which is a linear polynomial, not a quadratic polynomial, right, of degree 2. Okay, so the quadratic equation, right? So for a given quadratic equation, right, for ax square plus bx plus c, this is the formula for this, quadratic formula for this, to find the root, or you can say the zero of this quadratic equation, right? So it's like minus b. So you can see that minus b plus minus b square minus 4ac divided by 2a, right? So if you can see, it can produce two different set of roots, right? It's minus b square minus 4ac divided by 2a, okay? Or other would be b minus b plus b square minus 4ac divided by 2a. And a, b, c are the coefficient of the quadratic equation, and a must not be 0. We have already discussed in previous class. Otherwise, it will become a linear polynomial, not a quadratic equation or degree 2 polynomial, right? Okay. Let's see what is discriminant, right? Why it is important. So the b square minus 4ac component, right, in the quadratic formula is called as discriminant. Basically, it's the value of this discriminant denotes, if you can see in the graphical, it denotes the slope or how this parabola would behave, right? So this is decided by this discriminant, right? And the why it is significance, because if the discriminant is positive, right? If it's positive, then we will have two distinct real solution or real roots or real zeros of this quadratic equation, right? It can be rational or irrational, depend upon the value, whatever it comes, okay? So you will have two distinct real roots if this discriminant is greater than 0. If discriminant is 0, right? So we know that this formula is minus b plus minus discriminant, whatever is the b square minus 4ac, okay, and 2a, right? So if this whole thing discriminant becomes 0, then you will have only one solution, minus b divided by 2a, right? If it's become less than 0, right? If it's become less than 0, then we will not have the real solution for this. Then we will have two complex root solution for this equation, right? So okay, so this depicts why this discriminant is significant to solve a quadratic equation, right? Let's see few equations, few examples on that. Okay, let's take x square minus 4x plus 3, right? So if you can see here, a is this, right? A, b, and c. So a is 1, okay, b is minus 4, c is 3, right? So if we can calculate discriminant, right, it would be minus b square, which is minus 4 square, minus 4ac, right? So 4 ac, right? So it will become 4, the final value. Okay, so this is greater than 0, right? You can see the 4 is greater than 0. So we can conclude that we will have two distinct real roots for this problem, or real zeros for this problem, right? So let's put it into that formula. So minus b minus b, then this discriminant, right? And then 2 into a is, which is 1, right? So it would be 4 plus, so this becomes 2, right? 4 plus minus 2 divided by 2. So we will get two roots. One is 3 and one is 1, right? Okay, so let's take one more example. Okay, so here it's x square minus 4x plus 4, right? So a is of course 1, a, b, c, a is 1, b is 4, and c is also 4, right? So okay, let's calculate the discriminant. So minus b square plus 4 minus b square minus 4ac, right? So it would become 16 and 16, right? B minus 4 square is 16, and that's 4ac, which is also 16, right? So it becomes 0, right? So this is the which we have discussed the condition. If the discriminant is 0, you will have only one real solution, or you can say that a repeated solution, right? So if you will put it over here, so this component discriminant becomes 0. So this is irrelevant, right? Now minus 4, minus b, right, which is minus 4 divided by 2a, which is 1. So 2 into 1, 1, 2, and then x1 equals to x2, and then we have only one real roots, repetitive roots, you can say that, which is 2. Okay, let's take one more example before we end this video of unreal number, right? So x square plus 2x plus 10. This is also a quadratic equation. Okay, so here a is 1, right? Nothing is there. A is 1, b is 2, right? And c is 10. So if I calculate the discriminant, right, it will be b square, which is 2 square, minus 4, right? A, which is 1, c 10, 4 minus 40, which is minus 36. So here we can say that, I mean, discriminant is negative, so that we will have two complex root solutions for this 2-degree polynomial, which is a quadratic equation, right? So if I put everything in the formula, it will be minus 2 plus minus under root of minus 36, right? So we know that under root of so this can be written, minus 36 can be written as minus 1 root into 36, right? And we all know that this is iota, okay, and this is, if you can, 6, right? So that's why we have got this 6 iota, right? Minus 2 plus minus this discriminant, which is 6 iota divided by 2. Then if you will divide this number, so it becomes minus 1 plus 3 iota, and x2 minus 1 minus 3 1 iota. So here we do not have any real solution for this. Okay, the reason behind is that discriminant was negative. Okay, I hope you have found this video useful. If you have liked this video, give a thumbs up. Do like to subscribe our channel and share this video. Thanks for watching.